The hallway floorboards are cold under bare feet at 2 in the morning. Moving toward the kitchen for a glass of water, the eyes are still adjusting to the blue glow of moonlight leaking through the blinds. A tall, jagged silhouette suddenly looms in the corner of the room. The breath catches. Shoulders yank up toward the ears, knees lock, and a sudden, violent jolt of heat floods the chest. The physical body has just initiated a full-blown survival protocol before the conscious mind has even finished assembling the image of a coat rack. Today we are going to trace exactly how the nervous system pulls off this high-speed deception. Conscious vision is a brilliant liar. The continuous movie playing behind the eyes right now feels instantaneous. It is not. Reality is always on a tape delay. Light hits the photoreceptors, turns into electrical signals, and marches through a staggering sequence of neural checkpoints to be mapped, color-corrected, and identified. That takes time. A commodity the wild does not offer. A glass slipping off a counter demands action long before the visual cortex confirms the brand. The fingertips twitch. The hand snaps out and catches the tumbling glass mid-air, entirely on autopilot. The heavy thump of adrenaline hits the chest. Then, slightly later, the realization of what just happened finally dawns. There is a gap. A microscopic sliver of silence between the moment the body reacts and the moment the brain understands why. During that gap, the nervous system is running completely blind. To survive, it relies on a hidden anatomical back alley. Before we map the exact route this phantom circuit takes through the brainstem, if you are fascinated by the hidden architecture of the human machine, consider subscribing to the Minecraft to uncover more of it. Because that secret route operates on a strict, merciless timetable. It relies on a specific measurement of time so vanishingly brief that it dictates the survival of nearly every mammal on Earth. A tiny fraction of a second separating the quick from the dead. Standard vision requires heavy lifting. 1 million nerve fibers bundle at the back of the eye, forming a thick cable exiting the retina. This cable carries dense, high-resolution data backward to the thalamus, the main relay station near the center of the brain. From there, the data must travel all the way to the back of the skull, into the primary visual cortex. Here, the heavy computation begins. Neurons fire to detect edges. Contrasts are sharpened. Shadows are interpreted for depth and texture. Memory banks are rated to match the incoming shape against known objects. Is it a bear? A burglar? A pile of laundry? It is a deeply sophisticated rendering engine. It is also fatally slow. Evolution cannot wait for the visual cortex to finish its masterpiece. But what good is perfect clarity if the shadow has already lunged? The architecture demands a bypass. Deep inside the skull, long before the optical nerve reaches the visual cortex, a tiny fraction of fibers splits off from the main highway. They take a darker, older road. This is the superior colliculus. A primitive, ancient lump of tissue sitting right at the top of the brainstem. It does not care about color. It does not care about fine detail. It only cares about contrast in movement. A sudden shift in the visual field triggers this primitive radar, firing a signal straight to the amygdala, the central alarm bell. The alarm rings. Adrenaline dumps into the bloodstream. Blood pressure spikes. The pupils dilate violently. All of this physiological chaos unfolds while the higher reasoning centers of the brain are still waiting for the optical data to arrive. The body is already moving, already terrified. The elapsed time from the shadow flickering on the edge of the retina to the amygdala slamming the panic button is exactly 74 milliseconds. That is roughly twice as fast as the blink of an eye. At 74 milliseconds, the visual cortex has barely begun to sketch the basic outlines of the room. The conscious mind is completely in the dark. This reverses the entire way we assume sight works. The natural assumption is that a person sees something frightening, and therefore they become frightened. The wiring proves the exact opposite. The fear comes first. The fear response is what alerts the conscious brain to start looking for the source of the danger. The primitive brainstem hijacks the body, jerks it backward, and then essentially yells at the visual cortex to hurry up and figure out what we are running from. Standing in the dark hallway, the heart is hammering against the ribs. The lungs pull in too much air. The shoulders remain tight. The coat rack sits motionless. Nothing has changed in the physical environment. The wool coat is still draped over the wooden peg. The hat sits on top. But for 74 milliseconds, that arrangement of fabric and wood was a lethal predator. The body reacted exactly as it would have on the savannah a million years ago. It sacrificed accuracy for speed. It chose false alarms over a single fatal miss. Consider a hiker stepping over a log on a trail. A curved, brown shape registers in the periphery. Before the foot touches dirt, the leg jerks backward. The hiker stumbles, arms windmilling for balance, heart leaping into the throat. Only then does the hiker look down to see a curved stick resting in the dirt. A harmless piece of bark. The conscious brain feels foolish. It tries to laugh off the stumble. But the stumble was a masterpiece of biological engineering. Conscious vision overthinks. If the hiker had waited for the visual cortex to process the texture, length, and species of the stick to rule out a venomous snake, a real snake would have already struck. The fast, blind pathway makes mistakes constantly. It is designed to be paranoid. It sees threats in falling leaves, darting shadows, and discarded hoses. This paranoia carries a physical cost. Every false alarm forces the adrenal glands to flood the system with epinephrine. Glucose is ripped from storage and dumped into the muscles for instant energy. Digestion halts. Blood flow is shunted away from the skin and surface tissues, pooling in the deep muscles of the legs and arms to prepare for a sprint. A massive waste of resources. All for a coat rack. Yet, the math of evolution is unforgiving. 1,000 panic attacks over a shadow cost nothing but energy. A single failure to flinch costs everything. The optic nerve holds the physical evidence of this calculation. Roughly 10% of the nerve fibers leaving the eye never bother going to the conscious processing centers. They are dedicated entirely to the primitive bypass. 10% of the optical hardware is permanently assigned to watching the dark, waiting for a sudden movement, ready to pull the fire alarm. The hallway is quiet again. The breathing starts to slow down. The logical mind finally catches up, superimposing a neat, tidy label over the looming shadow. A coat rack. A piece of furniture. The muscles unlock. The cold floorboards register against the soles of the feet again. The walk to the kitchen continues. But the ancient radar remains active, silently scanning the edges of the dark. The illusion of being a purely rational creature, navigating the world through logic and clear observation, only holds up until the lights go out. Survival requires a faster, darker mechanism. A hidden sentinel that is always bracing for an ambush, ready to jump at shadows before the light even reaches the mind. If this changed how you see your own body, subscribe. There is far more hidden inside you that we have not explored yet. A like and a comment genuinely help this channel reach more curious minds, and that support is what makes it possible to keep producing these documentaries. Tell us in the comments what we should explore next.